So this video, along with the next two videos, will close out our study in Chapter 5 of our textbook. And again, these are so incredibly important. All three videos deal with z-scores, and I show you how to compute probabilities using StatCrunch, as well as how to cheat the system a little bit using StatCrunch if we have a question that allows for it. So again, we've looked at some examples for ACT scores for students admitted to Iowa State, and I just copied and pasted that normal or empirical rule over here so we could take a look at it. And we talked about, what percent are between two values, etc. But what we didn't talk about is what would happen if I wanted to know how many, say, scored 25 or better, because 25 is in here somewhere. So I could tell you how many scored 25.6 or better, but I can't tell you exactly how many scored 25 or better. Plus, we already know the empirical rule was just an estimation or approximation anyway. So what we need to do now is we're going to use our z-scores, and we can use a z-table, which you are certainly welcome to do, but for the sake of this class, we're going to use technology, which is StatCrunch. We have already worked on how to find or compute a z-score given our observed value, the mean, and the standard deviation. Now what I want to talk to you about is what to do once we have found that value. How do you find the percentage, an exact percentage, rather than using estimations from the empirical rule? So as you can see, I have StatCrunch open. I do have it open to my Unit 1 dataset, but it is not necessary for this question. What I want to do is I'm going to go to Stat, Calculators, and Normal. And this is the same thing we did a little bit ago when we used StatCrunch to calculate the values for our empirical rule. But what I'm going to do here is I'm going to leave the mean at 0 and leave the standard deviation at 1. So I'm not going to mess with those. And the reason for that is once we find a z-score, it is a standardized score for the normal model. So it would make sense that I would not want to change that. Now the first one I want to practice with is z is less than negative 0.42. So what I'm going to do is here, I'm going to choose my less than or equal to. I can't choose a less than, but that's okay. And here I'm going to put negative 0.42. And when I click compute, this value is my solution. So if they said what percentage of values are less than a z-score of negative 0.42, I would say 33.7% of values. I want you to also notice that the area that is shaded is to the left, which makes sense because that would be the area less than negative 0.42. So let's try the next one. Z is greater than 1.31. So here I'm just going to toggle this to greater than. I'm going to replace that value with 1.31. And now I can see what that picture would look like if I wanted to draw that picture. And also that it would be about 9.51%. The last one, z is less than negative 4. Hopefully before you even put this value in, you should know that this is a very, very small number. And I say that because we've already talked about the empirical rule, and we said that 99.7% of our values fall within 3 standard deviations, and this is 4 standard deviations away. So notice that my picture doesn't even have any red on it because it's outside of that 3 standard deviations. But what I do have is my probability, which is 0.00003176, or 0.003%. So we're going to do a question where we put this all together, and just because of the limitations of the program that I'm using, it won't allow me to go back and forth to do a screencast and a slide recording at the same time. So when I say use StatCrunch, I'm just going to show you the screenshots that I took from when I actually did use StatCrunch. But let's take a look. We had our question that we've been dealing with from the beginning that said, hey, we've got a normal model with a mean of 21.2 and a standard deviation of 4.4, which represented ACT scores for students who were admitted to Iowa State University. So I look at my picture here, and I always put draw a picture as one of the steps, but in reality, I'm very lazy, and I certainly wouldn't take the time to draw a picture with this kind of detail. Usually my picture would look something like this. I got a curve. I know in the middle I've got 21.2. I'm trying to find students who scored 25 or better, so that's going to be to the right of that and going to be shaded in. So that's about the extent of the picture that I would draw. And the purpose of doing that is just so you can kind of get a sense of what your picture will look like once you put it into StatCrunch. Make sure you're going in the right direction, etc. So then I'm going to find my z-score, and my z-score formula, if you'll remember correctly, is z equals observed, which is we call y bar, minus expected, which is the mean that's given to us for the population, divided by the standard deviation of sigma. And in our example, 25 is my y bar, that's my observed. 21.2 is my mean, or mu. 4.4 is my sigma, or standard deviation. So you can see what my z-score looks like is 25 minus 21.2 divided by 4.4. Again, if you're plugging this into your calculator, make sure you do that. And then I'm going to take this value, which is a z-score, and I'm going to come over here to StatCrunch. I've got stat calculators normal, which is what we've been doing, and I want to point out to you that my mean and standard deviation are 0 and 1. So I am not plugging these values in. I am using the z-score right here and a mean of 0 and a standard deviation of 1. Notice I've chosen greater than or equal to here, and I chose that because I was looking for 25 or better. And notice my answer was 0.19379. And what I want you to get used to doing, and I don't take off points for it in this first introduction, but if this is the second time going through the normal model, then I will expect you to use the probability notation. Here I would say the probability that my value is greater than 25, or greater than or equal to 25, because that's what I'm saying, is equal to the probability that my z-score is greater than or equal to 0.864, is equal to 0.1938. So again, this is called a p-value, and we will get into that in much more detail once we get to inference, but this is a good introduction. We always want to write a sentence that talks about what our answer means, and so in this case my answer means about 19.4% of students at Iowa State University scored 25 or better on the ACT. So again, that came from my 0.1938. I moved it 2 places and rounded. Let's do another practice together. We're going to use this example now dealing with SAT scores instead of ACT. And we're saying we have a score of 680. The normal model is 500, 100, which means the mean is 500, the standard deviation is 100. And we want to know what percent of SAT takers did we do better than. So again, we're going to follow those same steps we did before, draw the picture, find the z-score, etc. And then we're going to use StatCrunch and write the sentence. So again, drawing the picture, for me, just for my own benefit, is I'm going to stick 500 here in the middle, and then I know 680, and this one's pretty easy because obviously it goes by 100. So 680 is somewhere in here, and I want to know who I did better than. So that means, and again, this is where a lot of people fall off the wagon, all of these people I did better than. Okay, these people on the right, those people did better than me, but I'm concerned about what percentage of students is less than, not quite as good as my score, less than my score. Now I'm going to find a z-score, and the z-score again is going to use my observed value, y bar, of 680, my mean of 500, my standard deviation of 100, to get 680 minus 500 divided by 100, which is 1.8. Again, if you make sure you put your parentheses in the right spot. From there, I take that 1.8 and put it into StatCrunch. Again, note 0 for my mean, 1 for my standard deviation. And how did I get there? Stat calculator's normal, just like always. And I get a pretty high percentage, which makes sense because that's a lot of area to the left of my score. And so again, I would, I forgot to put my probability notation. I would say the probability that some score is less than or equal to 680, is equal to the probability that my z-score is less than or equal to 1.8, is equal to 0.9641. And then what does that mean? It means I scored better than about 96.4% of SAT takers. Now this is all well and good, and I know that I just did my example and I found 0.964 essentially as my value. But let's say I'm not the strongest person in math and I'm concerned that perhaps I didn't calculate my z-score correctly, or I just want to, feel good about having the right answer. Well, I can still go to Stat Calculators and Normal. And here's what I want to point out to you. If I keep my mean at 0 and my standard deviation at 1, then I'm going to use a z-score here. And this is what we computed last time, 0.964. However, let's say I want to cheat or check my work using StatCrunch. Well, I can change my mean and my standard deviation to the values, the raw scores given to me in the question. But notice if I then use 1.8, that is not the correct answer because I can't use a z-score unless the mean is 0 and the standard deviation is 1. So here I'm going to actually put in the raw score of 680, and hopefully you notice that that 0.964 and the shaded part of the picture looks the same as what we had when we did the math, when we did all of the work. Here's one last question for you to try, so I would really like for you to press pause, try this question, and then press play to check your work. Feel free to use StatCrunch to help you. So heights for females in America follow a normal model, 65, 3.5, and of course that means that the average woman is 65 inches tall, not 6'5", but 65 inches, with 3.5 inch standard deviation. If my height is 6 foot or 72 inches, what percent of American women are taller than me? So again, first step here is to draw a picture. And the picture that I'm going to draw just puts 65 here, and 72 is somewhere to the right of that, and it really doesn't matter exactly where. Whoops. So I'm going to put it somewhere over here, and I'm looking for people taller than me, and so if I'm here, taller than me would be to the right. And that's really the only purpose for drawing the picture, is taking a look at that and saying, well, obviously it's going to be way less than 50%. And obviously when I put this into StatCrunch, I'm going to be using the greater than or equal to sign. And now I'm going to perform my calculations, which means z-score. So my observed value, or the one I'm testing, is my height of 72. I'm expecting 65 with a standard deviation of 3.5, which gives me a z-score of 2. Now be very careful because some people are like, oh great, that's 2, I'm going to use my empirical rule. No, we got to go into StatCrunch to do that work. And so I didn't show you that StatCrunch printout, but again, I used a mean of 0 and a standard deviation of 1 and plugged in the value of 2 and used x is greater than or equal to 2. And this was the percentage that I came up with. And what does that mean? I would expect that only about 2.3% of American women are taller than me.